But those signatures only are valid for a short period of time, typically about a week. We must re-sign the zone, even if nothing changed. We have to re-sign the zone so that it has fresh signatures for another week before the first week ends. So every week, typically, best practice is about a week. It's up to you how long that signature validity period is, but typically it's about a week. So every week we need to re-sign just to keep the signatures fresh. And whenever any data changes, so if you are an ISP, you have a new customer, or a customer changes an IP address of one of their servers, so they change something in the DNS, that zone must be re-signed because the data changed. So the signature won't be valid unless you re-sign. So you have that change. Then about once a month, we need to change one of the keys, the zone signing key, so that people cannot perform a brute force attack on our keys and reverse engineer what the key is. So we change these keys once a month, and when you change the key, you re-sign the domain and you republish. And then once a year or so, we need to change the other key, the key signing key. And when we do that, we have to re-sign the zones, and we have to republish that DS record back to our parent domain. So this is the challenge. Beyond just learning what DNSSEC is, this is the operational challenge when we deploy DNSSEC. How are we going to do this? And what is very important is that we cannot make a mistake. Because if we make a mistake, if we forget to re-sign our zones before the signatures expire, or if we make a mistake when we roll a key, our domain could go dark, could be unvalidatable, insecure, and the resolver will not allow a client to go to that domain. It will not give an IP address for that domain. So it's much less forgiving than the traditional DNS that we've grown up with. Okay, so I mentioned security. Of course, we don't worry about security of the public keys because we publish them. But the private keys, we must keep secure. If an attacker can steal our private key, then they can forge our domain data and sign it with our key. And they are effectively guaranteeing that the answer is correct if they can do that, if they can steal our key. So in any implementation, we have to give some thought to how do we keep these private keys secure so that they cannot be compromised, they cannot be stolen by an attacker. Then there's the disaster. I don't have a picture of an earthquake, but I do have lightning storms and backhoes and other things that can go wrong. If you are signing your domain, and let's say you're signing and you are hosting your DNS in a data center somewhere, and if there's an earthquake and that data center is no longer available, maybe you have a backup data center somewhere, and maybe your customers can get to your domain and resolve your DNS through your backup DNS. You better have thought about a backup signing process for your DNS if you deploy DNSSEC. Those signatures will be valid, let's say, for a week. Let's say that you have a week in your signature validity, and an earthquake happens on day one, and you lose your data center. It's not quite as critical as redundancy, for example, in our routing infrastructure, or perhaps even our web servers, because these signatures are valid for a good period of time. But sometimes earthquakes and so forth can take us offline for even longer than a signature validity period. So we have to think about that. Are we okay so far? Okay. Okay. And then the last thing I touched on earlier was scalability. I know that there are a lot of ISPs in the audience, and so this is actually probably more important for some of you than, for example, maybe than for some of the government agencies. So if I am a domain owner of a government agency, I have one domain, it doesn't change very much, I want to deploy DNSSEC, probably I don't need to worry about scalability very much. But if I have many, many zones to sign, or if my zone domain data is changing very, very frequently, which can happen if you have a lot of dynamic DNS, for example, occurring in your environment, or, of course, if you are hosting lots of domains as a very large organization or as a service provider, then there can be a lot of change and a lot of signing that has to happen all the time. And so we need to think about whether we have enough resources, computing resources, available to us to sign that amount of data as it's changing. So much for the things we need to worry about. Let me talk a moment about the different types of solutions that there are out there available for people who want to deploy DNSSEC. And we spoke about bind. So there are open source tools and other free kinds of tools available to people. That's one category of solution. Things like bind or OpenDNSSEC that Mauricio spoke about this morning. And the good news is that those tools are widely available. They're free. They typically require an investment of time on the part of your organization to learn about DNSSEC and to learn about the tool so that you can actually utilize them and put them in production. And you will be responsible for thinking about and architecting a backup, a disaster recovery architecture. You'll be responsible for thinking about how scalable it needs to be. You will need to put those things in place yourself, which will cost time and people, resources to do that. But that is one class of solution. There are several other classes that are out there. So, for example, there are vendors of things called IP address management systems. Some of you may even use some of these. Many of those vendors are now supporting DNSSEC as a part of that solution. Typically, those kinds of solutions are deployed within your network, and they replace all of your, if you don't use an IP address management system today, typically they will replace all of your DNS servers with appliances, and then you'll have a nice user interface to manage that. Those solutions can support DNSSEC, but they come at a cost of replacing your current infrastructure. And you need to look a little bit carefully at the different solutions because they may or may not have good security around those private keys. So I don't want to make a blanket statement about them, but it's something that you should look at if you're considering that kind of solution. We have global load balancers from different networking vendors, and some of those vendors are now starting to support DNSSEC. So if you need a global load balancer because you have clients all over the world and you want to ensure very good performance for them, then there are some vendors that have DNSSEC-enabled global load balancers that you can use. If you don't need a global load balancer, then that may be a very expensive solution to just a DNSSEC problem. But it's another class of solution that's available.